Come guys, in this lecture we are going to solve this question, okay? And okay, the question, the mass here, this is mass A and this is mass B, and this is, sorry, this is block A and this is block B, and mass of this block is mkg, and mass of this block is 2 mkg, okay guys? And this is the spring, and its spring constant is K, and friction is absent. Yeah, there is no friction present at any, okay, there is no friction at any point, okay guys? And so, and system is released from rest with unstressed spring, okay guys? Initially this spring is unstressed, and and velocity of all the block A and block B is going to be 0. We have to find maximum extension of spring and maximum speed of block, okay guys? We can solve this question by two methods, but the first method is by Newton's law, by fundamental equation of Newton's law, F is equal to ma, okay? And second method is energy conservation, okay guys? The first method is quite lengthy, it's lengthy method, okay? And we are not going to solve here by work by Newton's law, okay? If you wanted to solve this question by Newton's law, you could do it by yourself, okay? Here we are going to examine the concept of energy conservation, okay guys? Okay, so first question which we should ask in our mind is energy is going to be conserved or not, okay? Is energy is going to be conserved or not, okay guys? So to determine that energy is going to be conserved or not, we should think about uh, forces, type of forces, okay? Type of forces, okay guys? So spring is spring, let me write down spring. Spring is conservative force, okay? Conservative force, okay? And here then we have force by gravity. Gravity, again conservative force. Conservative force. And we have there are two type force, another forces which is normal reaction, okay? Normal reaction. But good thing about it, it is not doing any work. Do not do any work. Do not do any work, okay? Okay, and another important thing is tension. Tension is a force. Tension force. So we have to think about work done by tension. So let's determine, let's analyze work done by tension, okay guys? This lecture we will be slightly longer than the usual lecture, okay guys? Because in by this question we are going to learn a lot of concept, okay guys? So this lecture will be slightly lengthy, okay, than usual lectures, okay guys? Because it's very good question and we are going to learn a lot of things from this, okay? So tension, let's analyze work done by tension. Work done by tension, okay guys? We are going to analyze here work done by tension first, okay? Whenever you find a question, you should ask first thing that is energy is going to be conserved or not, okay? And energy is going to be conserved if you had only conservative forces, okay? And work done by all non-conservative forces is going to be 0. Then energy is going to be conserved, okay guys? Then energy is going to be conserved, okay? So wait a minute. Okay, so here uh, tension, let's analyze the work done by tension. Okay guys, now first thing we should draw a free body diagram. Okay, we are going to draw free body diagram. Okay guys, yeah. Okay, this is this is block B. Let me write down here, this is block B. Okay, and let me draw another diagram for block A. Okay, this is block A, sorry, this is block A. Okay, and here in this direction this is the mg, this is the t, no, okay, this is the t. Okay, okay, so if you look at this, they are the forces, so the this is this force is by this portion of string, and this force is by this portion of string. Okay, now we are going to draw the figure diagram of this portion of string. Okay guys, so that we could analyze analyze the forces on spring. Okay guys, so it is important. Okay, so now I am going to draw figure diagram of this portion. Okay, a string between spring and block A. We are going to draw figure diagram of string between spring and block A. Okay, so be careful which string is. Okay, so okay, who has applied this, who has applied this force, okay, on block A, this spring. Okay, okay, so okay, okay guys, okay, let me write down now here, this is the T. Okay, let me make it slightly thicker. This is the T. Okay, this is the 2mg. Be careful. Okay, here this is again T. Why? You should think why. This is the T1. Okay guys, and this will be the T1, and this will be the kx. This will be the kx. Okay, okay, and here kx is equal to T1. Why? You should find it. Okay guys, why? Think. I am giving you hint. String is massless. Okay, string is massless. If string is massless, then kx is equal to T. String is massless. Okay guys, okay, now so we had draw the figure diagram. Now we are going to okay guys, okay, so we had draw the figure diagram. Okay, so let's suppose Okay, let's suppose this block B come down by amount. Okay, this block B come down. Okay, let me make it with another color. Okay, this block B come down by amount x. Okay guys. Okay, so the length of this spring is going to be constant, so this will move at this point. Okay, okay, and if this is the x, then this will be, if this is the x, then this will also be x. Okay guys. Okay, so this portion, if this move by amount x, so this is going to be moved by amount x. Okay, this is also going to be because this thickness is not going to be changed. Okay, so if this move then this, so the spring if this. Okay, so this is this portion, because length between this length. Okay, be careful here. This length is not going to be changed. Okay, the length between spring and this block A is not going to be changed. Okay, so this guy, so this end also move by amount x. Okay guys, this will move by amount x. Okay, so okay, let me draw. Okay, so okay, let's suppose this length is this length is L. So and this length is L. Okay, and this this A reached here. This A is here. Let's suppose this is the A. Okay, between this the block between this the block A, block E is here. Guys, so if you look at this length of this string is going to be increased by amount x. Okay, the length of this string is going to be increased by amount x. Okay, so just wait a minute. Okay, length if if block B moves x, then extension in string extension in string is x. Okay, is x. Okay guys, now I am not going to I am not going to explain this line. Okay, because it will irritate you. Okay guys, now if you are not able to understand, analyze why, so you should think about geometry of a straight line. Okay, think about you should think THIN think about geometry of a straight line. Okay, a straight line geometry. Okay guys, line geometry. Okay, this is a hint for you. Okay guys, you should think, you have to analyze distance. Okay, you will find that extension in spring is going to be x. Okay, so this is the very important thing. Okay, now okay, so okay, Okay guys, now here let's suppose this, this block come down by amount, this block come down by amount, this block come down by amount b. Okay, this block come down by amount x. Okay guys, so work done. So let me write down work done by spring, work done by string on a on b is equal to minus tx. Okay, and work done. Okay, let me string 1, let me write down string 1, because we had two string, this is the first string, this is the first string. Okay, from here to here, this is the first string, and this is the second string. Okay, so work done by string 1 on b is equal to minus tx. Okay, because displacement. Okay, similarly work done by string 1. Okay, string 1 on a this is equal to tx. So what is the net work done? So net work done by net work done by string 1 is equal to summation of this. So net work done is equal to work done is equal to 0. Okay guys, similarly work done by work done by string string b, so string 2 on a is equal to minus t1x. Okay, minus t1x. Okay guys, and work done by string 2 on spring. Okay, because this here, if you asked a question, who has applied this force? Spring on string 2. Okay, s2, this is the string 2. Who has applied this force on string 2? Spring. Then string will also apply a force on spring. Okay, and now here, see here, string is applying force on spring. Okay, let me write down, okay, it's your job. Okay, here this will be t1x. Okay, are you confused? Are you confused? Don't bother. Use Newton thought law. Use Newton thought law. Okay guys, here you should okay, work done on spring. Okay, let me erase it slightly. Okay, on spring is equal to t1x. Okay, so net work done here is again net work. This will be summation of these two guys. Okay, so this will be the 0. Okay guys, so now here what we have analyzed, what we had analyzed is, normal reaction do not do any work. Okay, why? Find it by yourself. Okay, think about dot product. Okay guys, and tension. Okay, work done by tension is going to be 0, we had analyzed. Okay guys, here work done by tension is going to be 0. So now work done by tension is going to be 0. Work done by tension is going to be 0. Okay, tension is equal to 0. Okay guys, so if you look here, then there are only two type of work taking place in here. Work done by spring and work done by gravity. Okay guys, and good thing is, these these two forces are conservative forces. Okay, so here, only okay, these two, this is doing, spring is doing work, and gravity is doing work, and both of them are conservative forces, so energy is going to be conserved. So let me write down. Okay, this is the very important. Okay, this is, let me write down. Okay, let me mark it. So energy is going to be, okay, energy is going to be conserved. So energy energy will conserved. Okay guys, so energy is going to be conserved. Why? Because work done, the conservative force is doing only work. Okay guys, okay, so now we had determined that energy is going to be conserved. Okay, okay, now come to the maximum extension. What happened at maximum extension? Okay, okay guys, uh, we know that kinetic energy kinetic energy is equal to change in kinetic. Let me write down change in kinetic energy. Okay, change in kinetic energy is equal to uh, F dot dr. Okay guys, change in kinetic energy is equal to F dot dr. Okay, so what is the kinetic energy? If you look at this, half mv square is equal to F dot dr plus c. If you look at this, okay, if you be careful about it, then this will be the kinetic energy. Okay guys, now here c is a constant. C will be some constant. Okay, so guys, so if I differentiate the velocity, if I am going to differentiate the velocity, what I get here, 1 by 2, okay, 1 by 2 m, and because mass is constant, differentiation of v square by dt. Okay, and this is, okay, okay guys, now here it is, see here, actually I should not differentiate with respect to time. Guys, here, guys, if I integrate this quantity, or if I integrate this quantity, so it will come as a function of r, as a function of r. Okay, yeah, for class 11th student, it is slightly difficult. but when we are doing integration, we should check here. Guys, here this f, here this is the r, so this must f must be in r. So velocity will be, this kinetic energy will be function of r. What is the r here? R is basically displacement. Okay, r is basically displacement. Okay, so kinetic energy will be the function of displacement. Okay guys, so I should differentiate it with respect to uh, with respect to displacement. I should I should differentiate it with respect to displacement. Okay guys, so here let me write down dv by dr. Okay, let me erase it. I should do dv by dr, and dv square by dr. Okay, by dr, and this should be equal to f. Okay, so if you look at this, I can write m v, okay, dv by dr is equal to f. Okay guys, is equal to f. Okay, okay, okay. Now here, see here, if if velocity is maximum, if velocity is maximum, okay, then guys, this f should be 0, because if velocity is maximum, then dv by dr, is going to be 0. Okay, sorry, dv by dr, if velocity is maximum, then dv by dr is going to be 0. Okay guys, so this f should be 0. Okay, so you get what I'm trying to say. When you solve this question, when you are studying such type of concept, you will learn that you will learn that um, velocity is maximum when net force is 0. I'm trying to explain why. Okay, I'm trying to explain why, because mv dv by dr is basically force. Okay, and I said that velocity is maximum, so this quantity must be 0, and if this is 0, this force must be 0. So velocity always will be maximum, always at a equilibrium. Okay guys, velocity will be maximum always at the equilibrium point. Okay, velocity will be maximum always at equilibrium point. Okay, so we are going, okay, so with the help of this concept, we can find maximum velocity. Okay, okay, let's check how we'll find maximum velocity. Okay, so if again here we should take the help of free body diagram. Yeah, it's quite lengthy question, don't bother, because he with the help of this question we are going to learn so many concepts, and we had learned how many concepts we had learned. First concept is we have learned that decide, we can, how can we decide energy is going to be conserved. Okay, energy is conserved only and only if work done, if only conservative force do work, if only conservative force do work, then energy is going to be conserved. Okay, first thing. Okay, and we have checked one by one that normal reaction do not do work. Okay, why do not do work? You should think about dot product. If you think about dot product, you will get your answer. First thing. Okay, second, here tension is present here, so we have to determine whether tension is doing work or not. Okay guys, so I had explained you that here, see, tension is not doing any work. Okay, and in the question it is given that friction is absent. Okay, so work done by friction is 0. So who is doing work? Only, only conservative force is doing work. Okay, and if only conservative force is doing work, that means your energy is going to be conserved. That means energy is going to be conserved. Okay, and okay, so the first thing we have learned, we had study in which condition energy is going to be conserved. Now after that we had understand you know at what is the condition for which velocity will be maximum, and how we know that at this condition velocity should be the maximum. So we had you know uh, we had analyzed the situation mathematically, and we have proved it that velocity will be maximum when force will be 0. Okay, because for maximum velocity dv by dr should be 0. Dv by dr should be 0. Okay guys, and if dv by dr is 0, then force becomes 0. Okay, so and due to okay guys, so due to this, people say, your teacher say it to you that uh, velocity is maximum at equilibrium point, because if I say equilibrium, then net force is 0. Okay, okay, so we have learned why velocity is maximum at equilibrium. Okay, so let's see the free body diagram. Okay guys, here, and guys, here if you see velocity of a and velocity of b always equal. Okay, va, let me write down, va is equal to vb. Why? Okay, you should think about what is the hint here. You should think about length of this string is not going to change. Okay, because string is inextensible. Okay, okay, so okay guys, so if velocity of b is maximum, then net force on b should be 0. Okay, so this means 2 mg is equal to t. Okay, and net force on a also should be equal to 0. So t is equal to t1. Okay guys, so if you look at this, and t1 is equal to kx, t1 is equal to kx. Okay guys, so so okay, so guys, if we look, if so 2 mg is equal to kx. So what is the x? What is the x? X is equal to 2 mg by k. Okay, okay, now we are going to, okay, we'll find what is the maximum velocity. Okay, after some time, don't bother. Now we are going to analyze what is the condition, when our max extension is maximum. What is the condition when extension is maximum? Okay guys, okay, so here you can analyze, so displacement should be mm, you know displacement should be the 0. Sorry, dx, variation of dx should be 0. Variation of dx should be 0. Okay guys, okay, okay, so I can, guys, let's see here, see, what can I write? Displacement, let's suppose displacement, if displacement is function of time, if displacement is function of time. Okay, so what can I, this is the x is equal to ft. So dx by dt, this is equal to f d of f dt. Sorry, this is equal to differentiation of f dt. Okay guys, and guys, if I say, just wait a minute, just wait a minute, actually I am going to, okay guys, okay, here, see here, if here this, I can write displacement as a function of, let's more suppose function of time. I can write displacement as a function of time. Okay guys, so dx by dt will be dx by dt will be equal to something like this. Okay, and if I say the displacement is maximum, so dx by dt, what should be the dx by dt? If displacement, if, let me write down, if displacement is maximum, okay, displacement is maximum, if displacement is maximum, okay, maximum, wait here, if displacement is maximum, then dx by dt, this must be equal to 0. Okay, and what is the dx by dt? If you look at this, this is the velocity. Okay guys, so at maximum, at maximum displacement, okay, at maximum displacement, or I can say extension displacement, or you can say extension, extension, at maximum extension, work done, sorry, velocity is equal to 0. Okay guys, at maximum extension, velocity will be going to 0. Okay, so till now we had learned a lot sufficient concept to solve this question. Okay, till now we had not solved this question. Okay, till now we had not solved this question. Okay guys, here we just learning the concept to solve, required concept to solve this question. Now we are going to solve the question and see, after learning this concept, how this is one of the most simplest question. If you know the concept, then this question is one of the most simplest question. Okay, so let's find out, let's find out let's going to solve the first question. Okay, now we are going to find out first question. So sorry, we are going to solve first question. Okay, what is this? Okay guys, okay, the question is, okay, let me write down, okay, here, okay, let's suppose maximum displacement is x. Okay, maximum, let's suppose maximum displacement is x. Let's suppose maximum displacement, okay, maximum displacement. What is this happening here? Displacement is equal to x. Maximum displacement is equal to x. Okay, so what is the okay, so if what is the initial energy? K1 initial energy is equal to what is the extension spring? 0. So half into K into 0. Okay, and let's assume, okay, let's go here. Let's assume at this point, at this point, uh, potential energy is going to be 0. Okay, potential energy is going to be 0 here. Gravitational potential energy is going to be 0, and when spring is on a stretch state, then its potential energy is going to be 0. Okay guys, so okay, and let's suppose this height is okay, and this height is this height from here to here, this height is h. Okay, so what is the initial potential energy? Initial energy, okay, let me write down. What is the initial energy? Plus mgh plus 0. Okay guys, okay, and now what is the final energy? Final energy E2. So what is the what is the extension spring? I had assumed that this maximum displacement, maximum displacement, this move by amount x, which is the maximum. So this spring also extends by amount x. Okay, I had explained here. Okay, so plus half k x square. Okay guys, now plus guys, here this block A is not, this block is again will be at this height. The height of this block is not going to be changed. Okay, okay, height of this block A, height of block is not going to be changed. Okay, so potential energy of block A is mgh. Potential energy of block A is equal to mgh plus mgh. Okay, and okay, now here this this block B come down by amount x. Okay, so here earth is doing positive work, so change in potential energy by earth will be minus of mgh. Okay guys, so that's why I have written here minus mgh, minus 2 mgh. Okay guys, now I have said that energy is going to be conserved. Okay, this means initial energy should be equal to final energy. So guys, I can write mgh, sorry, no, mgh should be equal to half k x square plus mgh minus 2 mgh. Okay guys, so mgh is going to be cancel out. What we get here, 2 k x square is equal to 2 mg, sorry, this will be no h, this will be x. Okay, this will be going to be x, pardon me, this will going to be x, 2 mg 2 mg x. Okay guys, so okay, let me extend it. आ जाओ नीचे, Okay, okay. So what can I write? X is equal to, if you look at this, this will 2 mg by k. Okay, 2 mg by k. So this will be maximum extension in string. This is the maximum extension in string. Okay, now we are going to solve maximum velocity. We are going to find out maximum velocity. Okay, okay guys, so actually yes, very difficult. I'm just moving in this direction. Okay, just pardon me. Okay guys, so till now we had explained that we had explained to you is that at maximum velocity, maximum velocity velocity. Okay, at maximum velocity, you know f is equal to 0. Okay, f is equal to 0. So what we find, t is equal to 2 mg. Okay, and this is equal to kx. Okay guys, so what is the x? X is equal to 2 mg by k. Okay, so this is the displacement at maximum extension. Okay, so maximum velocity, this is the displacement at maximum velocity. Okay, 1 minute, what we get here? Sorry guys, oh yeah, 2 mg here. This will be 4 mg, because 1 by 2 2 mg x. Okay, so that will be the 4 mg. 2 into 2 4. Okay, so here what is the x? This is the x at maximum displacement. Okay, now so what is the initial kinetic energy? Initial energy E1 is equal to, if you see here, that will be mgh. Okay, and what is the final E2? E2 is equal to, if you look, half k 2 mg by k square plus mgh. Okay, minus 2 mg. Okay, 2 mg by k. Okay guys, plus half, see here, this is the kinetic potential energy of string. This is the gravitational potential energy. Now I am going to write down kinetic energy. Okay, plus into 1 by 2 m into v square plus 1 by 2 into 2m v square. Okay guys, so here m v square. Okay, so now if these two quantities is equal, so what we get here, half, see here, 2 sorry, yeah, 2 m square g square by k. Okay, minus 4 m square g square by k, plus, if you look at this, 1 by 2 3m v square, and this is equal to going to be 0. Okay guys, so if we are careful, so what can I find out easily is that 3 by 2 m v square actually it's hanging a lot. This should be equal to, guys, uh, 2 m square g square by k. Okay, so if we are quite careful, you will find that this is going to be v square is going to be 4, let me write down, 4 m g square by 3 k. Okay, so what will be the v? So okay, now we have slightly some more space here. V is equal to root, it's not responding. It's quite funny. Okay, this will be 4 m g square by 3k. Okay, so this will be our maximum velocity. Okay guys, if you look at this question, solving this question is nearly 1 or 2 step. Okay, the finding solution of this question is not a quite great thing, but to analyze whether energy is going to conserve or not, why this energy is going to conserve, what is the role of conservative forces, okay, why why we always take potential energy due to earth is mgh. Okay guys, to know these things is very important, in for for the future chapters. Okay, you will use such type of concept in electrostate, gravitation, and center of mass. There's so many places where you can use this concept. Okay guys, so this is the very necessary to learn the concept behind this, these things. Okay, so and due to this reason I had expend a lot of time in explaining and analyzing such type of equation. Okay guys, and if you wanted to see how to solve this question, then it is a very small problem. It's nearly 1 or 2 line problem. Okay guys, thanks for watching. Thank you.